Testing. Hello everyone. In this video, we would like to follow the steps of the one who make the periodic table of elements, the trigonometry. You just follow the steps to come up with to enjoy the beauty of those elements which are grouped together. So and it comes to the chemist's interest on how come the determinant leaf will have such ability to group those elements together. So in the past, he didn't know anything about the electronic environment. They just know something, or what we call it as a chemical property. So what he has just done is to just get some they try to test its chemical properties by reacting with some other substances, such that for those elements which have similar chemical properties, they try to group it together. Okay, so but at that time, he still haven't know that it is more or less related to the number of outermost shell electrons, and indeed you find that it is just a matching of those. And indeed, chemical property of an element nowadays, we know that it depends mainly on the number of the outermost shell electrons. So I repeat what is meant by number of outermost shell electrons. We are going to take a look on the group. Okay, you are going to take a look at the group, and the last occupied shell, and try to see how many electrons are there. So we try to, in this video, we are going to take a look on that four main group elements: group 1, group 2, group 7, and group 0, and try to introduce to you what are the differences in their properties. Now, first of all, is on group 1 elements, we call the alkaline metals, 鈉金屬. So what are they in common is that they all have one outermost shell electrons in the outermost shell. We have got one electrons. So we have got lithium, sodium, potassium, rubidium, cesium. Francium is something radioactive from Cesium. What are in common is that when you say alkaline, is because once they react with water, they will form alkalis. Okay, the solution is alkaline. pH is greater than 7. So we will call that the metals, they are called alkaline metals. If you take a look on those table, we will see that most of them they are solid. One thing I would like to highlight with you is on here. Can you see the first three metals here? So the density is smaller than 1 gram per cm cube, which is even lower than that of water. So what is meant by that? If I going to put the metal into the water, so that three metals, they will float. Okay, they will float on the surface of the water because of the difference in density. Of course, what's next is about the reaction. So very rigorous reaction. So you will know this, and later on, you will see that melting point. You may find it decreases down the group. Boiling point decreases down the group. So what is that? You are going to ask about down the group. Can you see the word down the group? So you are in the exam, we usually ask you how to give a trend to show the difference in the properties of those metals down the group. Now, for example, you will see that they have relatively low melting point and low boiling point when compared with other metals. So the melting point and boiling point decrease down the group, which means that you are going to take a look on the periodic table downward from lithium to cesium, while the melting and boiling point decrease. So we call that the melting point and boiling point decrease down the group. At room temperature, they are silvery white solid when polished or freshly cut. Very soft, so you may see that here they as soft as it can be cut with a knife, and very low density, and lithium, sodium, potassium even flows of water. And what are the chemical property? Now the chemical property, they are of the following. 1. They all react vigorously with water to form hydrogen gas and an alkaline solution. So the equation is sodium react with water to form an alkaline. This is alkaline, we call that hydroxide. So sodium hydroxide together with hydrogen gas. So it is flammable. The hydrogen gas is flammable. So when I'm going to do this reaction, you are going to handle this with care. Now, second, they all react with non-metals to form compounds we call a salt. For example, sodium reacts with chlorine to form sodium chloride. Now, give you one more example, and you can get what I mean. Potassium plus chlorine. So what will we get? We've got a salt. We call that potassium chloride. Okay. So they are reactive metals. They must be stored in the paraffin oil, 石蠟油. So it is one of the fraction got from the fractional distillation of crude oil. So I put that metal inside that because it does not mix with water well. So this paraffin oil that will prevent those reactive metals from reacting with air and water vapor. In particular, we are going to talk about oxygen and water vapor in air. So here comes the chemical reaction. So don't worry about the reaction itself, just remember those the storage method. This is a type of storage method, 储存方法. So the metal is stored under paraffin oil to prevent them from being in contact with oxygen in air and moisture in air to have a further reaction. Okay, so you may see this one as a number four. You're going to talk about the reactivity we're pushing. Okay, so which means that what is the vigor of the reaction when I put it into the other chemicals, just like water. So the reactivity of this metal increases down the group. So it will be more vigorous. Okay, so you may see this, and I would like to show you one video which will best describe this scenario. Okay, so it is something about alkaline metals.
There are 6 alkaline metals: lithium, sodium, potassium, rubidium, cesium and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears. Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen, but this time corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all.
Can you see that the metals, they are very soft? And second, you may see the surface. The surface of it, it is very dull in color. And indeed, those piece of metal, once it reaches air, especially oxygen, it will react together to form metal oxide, while it is a dull color. Okay, white and dull color. So once you cut into cut it with a knife, you may see something silvery, but that silvery part, they will be tarnished. That means turn white very easily.
As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkaline metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time, we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our fifth alkali metal.
So this is what we would like to talk about, the alkaline metals we have with water. Very exciting, right? Isn't it? So and I would like to play it again. Okay, I would like to play again this.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears.
Now this is what you may see it as a lithium, a very soft metal. So you may see that it can be cut with a knife. Okay, while the surface is something black or maybe some white, because it is some oxide has been formed. Right, the reaction between the metals with air, the oxygen in air, to form some dull solid, which is metal oxide.
Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air.
Now you may see that we have shown you the 3 examples: lithium, sodium and potassium. And from the observation, while you cut it, just to see the freshly cut surface, now it rapidly tarnishes. Tarnishes means turned dull in color. So you may find that the reactivity increases down the group. And it is because of the metal reacts with oxygen in air to form metal oxide, which is in dull color.
Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our 5th alkali metal.
So you may see we have got a very terrible observation, right? Especially for the last one. Okay, so you may find it. That's why those metals should be put under paraffin oil, right? Because it reacts vigorously with water. So you may see that you may understand that saying the reactivity of these metals increases down the group, right? Very vigorous, so vigorous that it may cause explosion. We stop at all group 1 elements. Now, for group 2 elements, we are going to talk it as alkaline earth metals, 鹼土金屬. You take a look at the term alkaline earth metals, a little bit different from the word alkali metals. So the 6 elements, what are in common is that they have got 2 outermost shell electrons. Okay, so for barium, magnesium, calcium, strontium, barium, radium. Radium is something radioactive. Those the elements that can be found on the Earth and reacts with water to form alkaline. So we call it alkaline earth metals. Okay, so what you may see is quite similar to group 1, right? Solid, 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 but you may check for the melting point and boiling point. Yes, it decreases, but you may find that this data, right, it will be more than hundreds, which is quite high when you compare with group 1 metals. So take a look at the group 1 metals. You may see that, wow, the melting point and boiling point is very, very low. So you may see the difference between them. And for the density, those metals, they will sink in water, so they will no longer float. Only group 1 metals, that especially the first 3, lithium, sodium, or potassium, will float on water surface. So at room temperature, group 2 elements, they are sulfuric white solid when polished or freshly cut. They have low density when you compare with other metals except group 1. Okay, it's higher than group 1, but for other metals just like gold, silver, copper, it is rather have low density. They have low melting point and boiling point when compared with other metals just like this, because for those transition metal elements, their melting point is 1000 or even 2000 degrees Celsius high. Okay, very, very high. When you compare with this, it's just several hundreds. But of course, this melting point and boiling point is higher than that of group 1 metals, as said before. How about chemical properties? So they are quite reactive, just like group 1, but a little bit less reactive. So the reactivity, when you compare with group 1 elements, they are quite less reactive, but usually quite reactive. When they put it into hot water this time, hot water, they will still form metal hydroxide together with oxygen. Okay, they are quite reactive metal to acid, so they react with dilute hydrochloric acid to give hydrogen gas. Okay, so we may see magnesium react with hydrochloric acid to form magnesium chloride and hydrogen gas. They will all react with non-metals to form compounds called salts. Yeah, so you may find that very similar to group 1 metals. So you may see the chemical properties exemplified by reaction with dilute acid. So let's check it out.
In this experiment, we're going to investigate the reactions of different metals with hydrochloric acid and find out which metal is the most similar to calcium. Add a small piece of calcium, copper, magnesium and iron into hydrochloric acid separately. How vigorously does each metal react with hydrochloric acid? Which metal reacts with hydrochloric acid in a way similar to calcium? Magnesium. Both magnesium and calcium are group 2 elements in the periodic table.
So you may find that, wow, it is something about the same elements, right? In the period, same group in the periodic table, they behave very, very similarly. When you compare with copper and iron, which is what we call it as a transition metals, group 2 elements, they are generally more reactive. So you may see that. Okay, so when you compare with the reactivity of magnesium and calcium, you may find that calcium react more vigorously. So you may see that saying the reactivity of group 2 elements increases down the group. So this is what I would like to talk to you. Okay, so increases down the group, so we will be more reactive. So you may see that more reactive, and even more reactive. So what are they in common is for group 1 metals is also have a reactivity increases down the group. Okay, increases down the group. So shall we take a look at the chat point? So for sodium, magnesium, they are two common metals. The students want to compare the reactivity by putting them in cold water. You will see that which group do sodium or magnesium belong to the periodic table. So you may see that that equation. Okay, so what we get is about which group sodium and magnesium belong to which period. So sodium, it belongs to what? Group 1. While for magnesium, it belongs to group 2. Okay, because it has the 1 and 2 outermost shell electrons respectively. Okay, so metals, they are usually shiny, but sodium is rather dull in color. Why? This is something about the chemical reactions with oxygen in air. Okay, so you may find that it is because the sodium reacts with oxygen in air to form sodium oxide. So a new substance, right? Sodium oxide. Sodium reacts with oxygen to form sodium oxide, and you have going to relate the gray, right? So which is gray in color? So the gray color refers to the formation of a new substance, sodium oxide. C. The student put magnesium in the test tube of cold water. They state the expected observations. Cold water, you see the word, and explain the answer. Okay, first of all, it sinks because it has a higher density than water, so this sinks, but it shows no observable change. So you are going to give me the two reasons. Okay, sinks, number 1, no observable change, number 2. Reasons for number 1. Okay, so you may see that magnesium has a higher density than water, so it sinks. Number 2 is about the magnesium. Okay, as magnesium does not react with water, so it has no further change. Okay, why? Because magnesium, when you compare with sodium, you know that sodium is quite reactive, right? So it is less reactive than sodium, so you may find that it's less reactive. Okay, so take a look on D. The student then puts sodium into cold water in a trough. The sodium moves around the water surface and dissolves into a given solution. Give other observation. Okay, other observation besides dissolving. So you may see that sodium melts into a silvery ball. Okay, some sound, we call it hissing sound. We've got a very that sound, we call it hissing sound, is detected or is heard. Okay, DETECTED, or other possible answers that you may find. Is it suitable to carry out this experiment in a test tube? No. because it is rather dangerous, right? Because the energy released by the reaction may break the test tube. Okay, why? Because it releases a lot of heat. Okay, it releases a lot of heat, so it may break the test tube. So suggest how the student can show that the resulting solution become alkaline. The solution become alkaline. So you are going to test it, right? You may have two methods. One is just recall what you learned from 2IS. Okay, from 2IS. The solution can be tested by what? Red litmus paper. 紅色嘅試紙 It turns blue. Okay, to turn red litmus paper blue. Or maybe you may use the same method by dropping a few drops of a sample onto a piece of, yes, that's right, pH paper. Do the same thing, and the color will change to blue. Okay, so this is also possible. Is sodium or magnesium is more reactive? The answer is sodium, group 1. Okay, sodium is more reactive than magnesium. Okay, more reactive than. So this is what I would like to talk to you about this chapter. Okay, for group 1 and group 2, they're quite similar. So you may see another video we'll have got a further talk on group 7 elements as well as noble gas. Group 0. Okay, so see you.